Good morning.
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 Crispin, in what class are you? Regular extension? Hello? Crispin. Okay, the number is quite good. We'll be getting started. Have you checked your stud master?
Yes.
Okay. So if you've noticed, we've just started like you're in grade 10. Yes, but you are not in grade 10. You are school leavers. We are teaching chemistry like you're in grade 10. We haven't done anything applied yet because we've concluded that maybe what you learned you've forgotten. So that's so I'll mute all of you. You can still ask questions. You are entitled to ask questions because that's what we're doing. We're perfecting the lessons and improving to use this our Zoom.
There's a list that you posted for the elements, the ions. Are we supposed to go into details, or we just know the definition and just a little bit of basis?
Well, that list is a summary. Say you should have known this. So we are starting. Today's lesson is writing of formula of compounds. I think this was there even in the previous lesson, but then we just wanted to focus on that today so much. So as you know, in chemistry, formulas are important because they are abbreviations of compounds. So I mean, if someone writes, say, CaCO3, the person who's reading maybe the news should think CaCO3. But for the chemist, that is a name to say calcium carbonate. So they are very important. We don't do word equations. Word equations are done at grade 8. At grade 10, you are introduced to symbols and formulae. So elements will be symbols when you write in your chemical equation. Compounds will be formulae. So those are the things that you'll be doing. So we are describing now a formula must look. Although the relevant skill, we may do it next week, where if you're given 2 elements, you predict the formula using oxidation numbers. As I've told you, at this level, we don't say valency, we say oxidation numbers. So we say a compound shows the symbols and the ratios of the atoms of the elements in a compound. So meaning, if you have, say, sodium chloride, there is 1 atom of sodium per 1 atom of chlorine. So is NaCl. This is always in the lowest ratios. Covalent compounds are different because sometimes covalent compounds will have not always in the lowest terms. Ionic compounds are always empirical because they always just show the lowest terms. So we'll talk about that as well, empirical and molecular. So now, those are the things. So H2O also, it means in a molecule of water, there are 2 atoms of hydrogen and 1 atom of oxygen. So that is the case. The formula tells us which elements are composed, which elements make up the compound, and they also tell us what is there for the formula unit. So those are the things. There are so many compounds. They've said you don't, instead of writing HHSOOO, you write the numbers as subscript. So like say, if you say H2SO4, it means there are 2 hydrogens in that molecule and 4 oxygens in that molecule. So those are the things, H2SO4. So there are even examples of compounds. It's very boring, I know, because you're like, it was a So those are the things. Number of elements. So those are the things. So we've explained there. The symbol will tell us the elements that are there. The numbers will tell us. The numbers are written as a prefix. Someone was asking, what is a prefix? Because what did I say is a prefix? So a prefix is a number like this, below a big number like that. So this is your prefix, the 2. So it means there are 2 hydrogen atoms in this. Or 4, there are 4 oxygen atoms. Then for the nitrate, this one is a nitrate. All of it is an ion, is a polyatomic ion, so you treat it as a single entity. So you always write these polyatomic ions in brackets, and then you indicate the 2. So this thing tells us that if now someone asks you how many atoms are there, you multiply 2 times the nitrogen, so there are 2 nitrogens, and 2 times the oxygen, which is 3, meaning there are also 6 nitrogens. So these are the things that are there. So the characteristics of formula are as follows. The formula of the compound contains the symbols of all the elements in the compound. So if say H2O, it means you have symbols of hydrogen and oxygen, the ones that make up water. Then when the formula contains 1 atom in an element, the number 1 is not used as subscript. I'm sure you saw it when we were saying sodium chloride. We didn't say Na1Cl1. So the number 1 is always dropped. Even when balancing, we don't put a 1 in front, because when you multiply something with 1, it just remains that same thing. So that's the case. So we don't use the number 1 when you're writing a formula. So when it contains 2 or more, you write the number 2 or 3 as a subscript. So those are the things that are there. If there's a group of atoms, you treat it as a unit. You treat it as a unit, and the subscript must be placed outside. Like that number, that unit should be in brackets. Then you put a subscript at the end. So there are so many examples. Then, if you have just 1 unit, there's no need of putting in brackets. So you say if you have NaNO3, that's sodium nitrate. The nitrate is a polyatomic ion. It's supposed to be treated as a single entity, but since there's only 1 nitrate group there, there's no need of brackets. But then when you have calcium nitrate, the nitrate group is placed in brackets. So then there's explanation. So those are things that are there. So some formulas will indicate the numbers that are there. So the last point is to say, that's number 5. The formula does not show the arrangement of atoms in space or the shape of the molecule. They just show the elements and the numbers that are there for our chemical bonding. If we need to know how these atoms are arranged, that's a topic for another day. When we look at molecular bonding and ionic bonding, how these things like are placed in a lattice, how they form bond angles and all. So that's the case. Then this is a point here, chip shom guys. So one of the things, the composition is always the same. It's even the same statement that we talk about when we say law of definite composition. So in water, even if you have 2 grams water, you have 50 kg water, 20 liters. By mass, water will always contain 11.2% hydrogen and 88.8% oxygen. Always, the composition of compounds is always the same. So by mass, if the compound, if you have carbon dioxide, the composition of carbon and oxygen will always be the same, regardless of the amount that you have of that. So the key word there, there's what's called natural law. This one is simply a summary of the laws or observations that are based on nature. So a summary of anything that's based on nature they are called natural laws. So now the 2 that we're interested in are the law of definite composition, which we are from explaining about the composition of elements, which states that a compound always contains 2 or more elements chemically combined in a definite proportion by mass. Definite, we love it in chemistry, but it just means the same word as fixed. So if that's what we're from saying to say, if you have carbon and oxygen, carbon dioxide, the percent by mass of carbon and the percent by mass of oxygen in carbon dioxide, they'll always be the same. So now what we are mentioning, what hydrogen and oxygen. Now what at 11.2 hydrogen, 88.8% oxygen. So those are the things. Naomi, you are going through also? Naomi. Madam Temba Naomi. You are too mute, guys. Mwashira shila muri weki.
Sorry. Sorry, sir. I was trying to go through. I didn't know that I had touched on the editor pen.
Oh, nshaje tukala na editor pen. Madam Tembo.
So there's a pen that's showing, or the pen, so I don't know what it's called anyway.
Okay. Let me look for it. Yeah, ilikuisa. Apapa that annotate.
It's showing on my left side.
Okay, me I can't see. I'll still navigate. All right. So that, you can switch off the mic, man.
All right. Gift she.
Piangeni mami. The other one.
It's the kids. Sorry.
Mwalikuwa tenganda?
No, my niece.
Mwakana na maka, eh? Alright.
Just okay, sir.
Okay, guys. So I want to go to the law of multiple proportions, which says two or more elements may combine in different ratios to provide or to produce more than one compound, which is also true. If you look at the same carbon and oxygen, you have carbon dioxide, which is very useful. Carbon dioxide is used, it's used by plants to photosynthesize our food. For all the green plants, you did photosynthesis. Carbon dioxide is there. Carbon dioxide is also a good absorber of heat, meaning it's also responsible for the natural heat that we get outside. So that's CO2. But then the same carbon and oxygen can combine to form carbon monoxide, which is a highly poisonous gas. It chokes you. The iron in our blood have an affinity for carbon monoxide than oxygen. So when you need oxygen to respire, and then there's carbon monoxide in the air, your body will get a carbon monoxide, and it has actually killed a lot of people. Most of people have died of carbon monoxide poisoning without knowing, because it's odorless also.
Hello.
Mom, go to mommy.
Hello.
No, go to mommy. So those are the things. So now, the summary is there per last step. 1, the composition of a particular substance will always be the same, no matter what its origin or how it was formed. The composition of a particular substance. So oxygen, whether na waipangira kulabu, whether yapangira, not oxygen, let's say H2O, na waipangira kulabu, waipangira oku, the composition will always be the same. Now, utwasa misetinga mbuni kwa ushendo sanati, Canadian water and the Zambian water, which one has a bigger composition? Masetina. Now, some of you, because you believe in Canada, we say no, definitely Canadian. So those are the things. Then the composition of different compounds formed from the same element will always be unique. As I've explained, carbon monoxide and carbon dioxide, very different. Even their properties are different. So those are the things that are there. So that is basically the case. The examples of the same things that we've put there. Then I'll put a summary, I think. You pardon with me. I'll put the summary. Last just on elements and compounds. We'll move to the next thing next time. So this is as much as I said. So you have carbon, if you have copper chloride and copper 2 chloride, those are different. You've seen the percentage by composition. Methane, octane. We're trying to emphasize law of multiple proportions or multiple composition. So this one, the law of multiple proportions, will tell us that two or more substances may combine in different ratios to form different compounds. And these are the ones, e.g. glucose, that's the sugar in our blood, the sugar that we need in our blood, which is formed from respiration. Then alcohol, which is ethanol, but ethyl alcohol, methanol is useful as a solvent, But when you find what's called methylated spirit, they spike ethyl alcohol, which is ethanol, while we come onto methyl alcohol to make it a poison, because the methylated spirit has the methanol, which can make you to go blind. So I'll put the summary. You bear with me. The summary is simply the same things that we've been looking at together. So I'll put it there. I just want to ask now, are there any questions? Because in them pera for two non. If in them beloku fin fiatila, now assembly my elements nama compounds at this stage. Yes, Moffat.
Yes, I've got a question on the law of multiple composition.
Yes.
I've not like understood what you said, sir.
No, law of multiple proportions, in fact. What that means is that if you have two elements, they don't just form one compound. They can combine differently to form more than one compound. The example I gave was carbon dioxide and carbon monoxide. Or the three things we mentioned here, glucose, ethanol, and methanol. They all have carbon, hydrogen, and oxygen. So those three elements, carbon, hydrogen, and oxygen, they can combine differently and form different things. That's what it means by law of multiple proportions. It just means that two things cannot just form one compound. Two elements cannot just form one compound. They can form more than one if they are bonded differently. That's the meaning of law of multiple proportions. Are we together, Moffat?
Yes, sir.
I have a question, sir.
Chose, yes.
Sir, repeat on the law of definite composition. I didn't understand on that one.
Law of? Chose, law of?
Law of definite composition. Law of definite composition.
Yes, definite
I didn't
means,
understand on
yes.
that. Yes.
Definite means fixed. Definite means fixed. So what we're trying to say there is that for law of definite composition, we're trying to say if you have water, the percent by mass will always be the same. It will always be 11.2% hydrogen and 88.8% oxygen by mass. So elements like compounds, regardless of their mass, if you have say 2 kg of the same compound, 10 kg of the same compound, kilograms of the same compound, those ones will always have the same composition by mass. So even if you are told that you have 2 kg water and 10 tons of water, the same mass, percent by mass, that's what they will have. The percent by mass is always fixed. That's what it means, Madam Chose. Gordon.
Yes, sir.
Yes.
I just want guidance on the characteristics of the chemical formulas.
Yes.
On the third point, yes, where you were explaining about the reaction of a certain metal with a nitrate. So I wanted guidance where the type of the nitrate will be determined by the kind of metal, because my observation was the time that a sodium reacted with a nitrate, it had a different formula in a case whereby it was a group 1 metal. Then the type of nitrate didn't involve the palladium, something like that. Then when it reacted with the calcium, which is a group 2 element, it showed a group 2 metal showed a certain type of nitrate. So I'm trying to get an understanding: is the nitrate, the type of nitrate group or the type of nitrate determined by the metal Shanshanza?
Your question is very tough. Your question is very tough. the nitrate is the same, except the nitrate has overall oxidation, if you want to say overall valency of -1. So that word parenthesis, that parenthesis just simply meant there was no need of putting that nitrate in brackets. Why? Because there's an overall oxidation of -1. When it combines with a valency of 1 also, which is the oxidation of sodium plus Na plus, they just form, like there's no, it's like sodium, the nitrate is the same valency as chlorine. So the way we write sodium chloride, that's the way it is, like there's nothing. But then since calcium is in group 2, when it bonds with a nitrate which has a valency of -1, it means you need 2 nitrate groups. That's why you always put in brackets and say NO3 open brackets 2. That's what it just simply meant, Mr. Wadiasa. Chose, did you get what I explained, Pavespa? Mr. Wada, have you understood? The nitrate
Yes, sir.
group. Oh, okay.
Yes,
Are
sir.
there,
I've understood.
Yes, sir. I've understood.
okay, cheers. Are there any other questions? Any other questions? So you are expected to know these things by now. If you don't, you need to work hard. What is an element? What is an atom? What is a symbol? What are groups? What are noble gases? What are the alkali metals? What are alkaline earth metals? The halogens, representative elements, transitional elements, metals, non-metals, metalloids, diatomic molecules, compounds. What is a molecule? What is an ion? What is a cation? What is an ion? What is a chemical formula? What is a subscripts? What are subscripts? These ones, like no one will ask you define subscript. No one. Subscript, if you remember, is simply like a number after a formula or a symbol. So that's the way it is. So that's then what's natural law, and what's the law of definite composition, and the law of multiple proportions. So if you know these, or if you know 70% of these, the student doesn't. Davis, there's noise there. There's no.
Oh, sir, I have a question.
No, she does.
Sorry. I have a question.
The mic. Yes.
Okay, yeah, sir. The question is on metals, is it necessary that we know also how to extract them from their ores?
Oh boy, the mind today. You're not doing metallurgy, so don't bother so much. You can have ideas of how this is formed, what ores it has, just because you love the chemistry, but it's not really like we don't look at the blast furnace here. It's not applicable because you guys are doing life science. Blast furnace, kopo for ingila, yafuma kunani, simwatina to say ni chemistry actually. So we just have to know reactions like this basic chemistry. In fact, what you're running into is organic chemistry. There was another hand. Tracy. Tracy.
Sir, yes, I wanted to ask about the subscript. Is it the same as prefix?
Prefix, mami, ni kala word before another word. Like midi, meter. Midi is a prefix. Stevo? Momvale? Midi is a prefix.
No,
Midi,
I can't get you, sir.
I'm saying prefix is a word before another word to emphasize meaning. Like millimeter. Midi is a prefix. Are you getting? But then there's a what? Which one? Subscript.
Yes.
Is a number like H2O. The K2 there, you write it as a subscript. a number that is written beneath a word or a letter to emphasize something. That is
Yes.
the subscript. Are you getting? So pre is word
Yes,
before
sir.
another word. Crispin, raise your hand again.
All right.
So I don't know if it is just me. This thing that you're showing here, you've posted them on StudyMaster, right?
Yes.
But on my part, I don't know. I'm just able to see the previous ones that you sent, like the part 2 of elements and compounds.
But by now participated, I mean Isaac achip chama questions ayapya sana. Taba muno Isaac. Even more fat.
He's here. Probably it's just him having technical difficulties.
So just refresh. All of you have seen your StudyMaster. Eh? That's the first thing I ask. Maybe I didn't. Maybe it was pending. I didn't open the class. But then the fact that some people are participating means that you have to refresh. You have to refresh, Mr. Crispin. You have to refresh so that you're able to access whatever it is that you want. Any other questions, guys? Any other questions? Can anyone claim that they know the definition of everything here that we've listed in board here? Who knows the definition of all these? Guys, okay, who knows the definition of 90% of these? Okay. We need you guys to go through these things, always understand them. So our next topic,
I don't know if I missed it or something wrong.
Who's this? Mwamba Fyokulanda Tatu. Who's this?
Humphrey.
Yes, Humphrey.
Sir, I don't know if I missed the, because previously I've not been attending regularly, so I'm a bit behind. This one here, natural law, sorry, I've not did anything about this.
Oh, natural law was explained today. It's not something to keep you very busy. Natural law just simply means a collection of laws or observations based on nature. A collection of laws or observations based on nature. So these two laws, because they're the important ones, the law of definite composition and the law of multiple proportions, those are natural laws. Like people have found these things to be the same throughout the world. So that's all. Kala tinyaka we defining our natural law, because and it's very good that it's the only one that you've said you haven't heard about. Humphrey, it means you are going in the right direction. Because no one will even ask you to say what is natural law. But you are expected to know the law of definite composition and the law of multiple proportions. So the rest of the things, if you understand, then you are okay. Are we together, Yasin Fukwe? Yasin Fukwe, are we together? iPhone?
Yes, we are together, sir.
iPhone.
Yes, sir. I don't know if it's only me, but I'm in need of the recorded videos, even if you don't edit them. Yes, because
Me one naisanga pa Facebook. How can I not edit them? I'm editing.
you can just leave them in the comments. It's still fine.
No.
Okay,
I
how
have to work
long?
on them. By tomorrow, I'll give you all the videos.
Okay, thank you.
Yes. Doris, you have a question?
Sir, the notes on the previous lesson. Yes, sir. The
Yes.
notes on the previous lesson are still incomplete. What's going to happen?
Oh, thank you for the reminder. They're still incomplete. What do you mean incomplete? Like screen tired Monica Yonse?
They are still cropped. We can see, but
Oh, I'm sure it's the nature of your phone. Ask Abena iPhone. Ask Abena iPhone.
Arena iPhone, can you see?
No, iPhone.
She's
iPhone
not the
number.
only one. It's everyone of us. The notes are cropped.
I know, but your iPhone, I'm sure now got Diana.
Even
So
me, sir,
now
they're not cropped. They're just showing.
But then even the words, the ends, they're not so bad that you can't manage to finish it on your own. It's just that
Me, they are
3 letters.
showing.
Oh, so some people it's showing, some person.
Universal cropped.
Okay. But guys, what my complaint is, when I say any questions, all you get are complaints. Tamkwatama questions, but if you never trace and be sure.
Yes, sir, I've got a question. I heard something about negative. I don't know if it was negative valence. What was it about?
We'll talk about that when we look at oxidation. Valency is the same word as oxidation number. I'm sure you remember valency, like to say sodium has a valency of +1. I'm sure you remember those. Valence, calcium has a valency of -2, of +2. I'm sure you remember those. Calcium has a valency of +2. Then chlorine has a valency of -1. Those were there. So we'll look at them. We'll look at them. That's a very key topic to talk about oxidation. It's one of the most important in your language of chemistry. Okay? So guys, we are only remaining with yes. Madam Tambo, fast.
Okay, I want to ask, like when you want to define the alkali metals, how are you supposed to define them? Are we supposed to use the valence number or
no, just say
maybe
alkali
that you're
metals.
supposed to use?
Just say alkali metals are group 1 elements. Alkali metals are group 1 elements. That's all. You don't struggle so much with these ones. What we want is just to know, do you know where they are, what they are? Okay? So don't bother with the logic. That's guys, I think we've had a nicely participative class. Let's keep up the spirit. It means we are getting somewhere. So
so one last thing. Yesterday you had posted in the group that you had put some solutions on Study Master, but we couldn't find them.
No, just check the PDFs.
We tried to download, but it's saying file error. I have file error.
Oh, mami, mwambe report patumara na mmonade.
Yeah, sir. Yeah, so it's saying file error. I couldn't download. I'm sure there's someone else who had posted in the group.
All right, then I'll put it when we do the physics again.
All right, sir.
All right, good day, guys. Enjoy the day.